Hello, networkers, and welcome back to another episode of Ask the Network Engineer, where I will answer one of your questions. And in this video, we're going to do speed round number 6 this time. And I'm going to answer 4 questions in this particular episode. And the very first question is by HD Flight Sim. And he has a nice long comment, so you can pause the video and read it. There's a lot of good information about his experiences and basically understanding about the challenges of being a network engineer. So definitely read through it. Now, his particular question in this comment is at the bottom, and it is, should I start my career as a network field engineer or as a technical support engineer? That's pretty good. Let's talk about that very quickly. Okay, so they are both very good options for starting out, and they provide very different benefits starting out based on your career. When you're a field technician, you're getting the benefit of getting hands-on experience. That's very good because that's really the big part of what many of you guys are looking for, is getting actual hands-on experience of touching the equipment, doing configuration. That's a big one. But technical support does more of giving you support and troubleshooting experience, which is definitely a big part of what your job will be. Now, if you're able to kind of get a job that does both, then that is a very good thing, because doing that will give you exposure for, again, you got hands-on configuration experience, and now with troubleshooting and support experience. It's a great combination of all of that. Now, for me, I started out doing technical support in regard to networking. Like, I started out basically in a NOC. Actually, I was at Cisco, and at Cisco there, I didn't really do any kind of field engineering work. I was on the phone talking to clients, helping them through configuration and support. So they're both good options either way. So don't think that if you don't do that, you have to do both. If you get one or the other, it is still a very good starting point in your pathway of becoming a network engineer. And his next question is from Britt Nickel, and he asks, can you explain some examples of projects for adding onto a resume at a CCNP level, an intermediate level? So it's really hard to answer that because it will all depend on the job roles and responsibilities. Each company will be different. So your roles may be more limited or it may be more advanced. It all depends on the organization. I've seen some companies that basically have their CCNP engineers do advanced BGP. So that does happen. But to kind of give you an idea of the type of projects that a CCNP, an intermediate network engineer, typically does, it is mainly with routing and with switching, with security, with internet type solutions, and with troubleshooting. Those are the big components of what a network engineer would typically do at an intermediate level. Now, when I say routing and switching, then I'm talking about like a LAN campus with a core and access switch. I'm talking about routing protocols like OSPF or EIGRP, and switching protocols like span tree, VLANs, 802.1q trunking or VLAN tagging basically. Security in regards to access lists and configuring firewalls and the many next generation firewall features on that device. Internet, that probably means not BGP, because I view BGP as more as a senior level position. Because it's very different from IGP protocols like OSPF, and it can be very dangerous if you do not know what you're doing. Okay, but also troubleshooting. That's going to come with the territory for anything that you do in this field. So use some of those things as a baseline for the type of projects that you can basically expect to do at a CCNP level. And this is another question by Britt Nickel, and he's certified as a CCNP. So his other question was trying to understand what kind of experience he should have or to look for to get that on his resume. So his questions are more focused around that. So it's a very good set of questions. So one of his questions is he's looking for more like real world experience of network support. Okay. And really the best example for that is, or the best pathway is looking for a job that does technical support in a network centric type company like Cisco or Juniper, things like that, at an ISP. Doing technical support in a network-based company is definitely a good place to get started. But his specific question here that I want to talk more about is, can you tell me any real-world network diagram infrastructures for a small company with Cisco routers and with switches? So in a previous episode, I talked about classifications in terms of what is a small network, an SMB, a medium, and a large size network. Now, in your particular question, you're talking about a small base network with routers and with switches, okay? And that implies that you're looking at a network with about 20 users. So this right here, let me throw up the picture. This is basically a typical picture of a diagram for most small size networks. Very simple. And really what you get here is you have a collapsed core. Now a collapsed core switch is basically a switch that contains multiple switching functions. Like it is acting as a core switch and maybe as a distribution switch. So that's a possibility. Now in a 20 user environment, and we're assuming that they have probably a handful of other like servers, like maybe 1 or 2 servers and maybe an access point here and there, or maybe a network printer, but that could be wireless. That's definitely possible in small size networks. Then you're going to have a single layer switch, a collapsed core. And that's where everything is plugged into that, your desktops, your servers, things like that. Then from there, they will likely plug into a firewall. Now for small networks, they don't really have a router and a firewall. That's kind of an overkill. They usually have a firewall with an Ethernet handoff that plugs directly into their internet, and they're off and running. Now, some small companies, depending on the wiring closets, they may have a collapsed core, but they could have access switches. Maybe there's a particular wiring closet that all the cabling for all the desktop goes into one particular room. So then from there, all the user endpoints, the printers, even the access points, they're all basically plugged into an access switch. And that access switch is basically connected uplink to a core switch. And off of that core is where you have maybe a couple of servers and other kind of critical infrastructure components. And one of that will likely be a firewall appliance that is then connected up towards the internet. I'm not seeing a lot of router deployments in most small size networks or SMB size networks anymore. I see routers more for medium and larger size networks that connect into a wide area network, into an MPLS, or connecting towards the acting as the edge router that has, basically doing BGP and using hardware like the Cisco ASR 1000 series, for example. That's what you typically see for routers. Now, for smaller companies, I'm not seeing much of that anymore. I think, again, firewalls are becoming really the main center point for Cisco networks. So that is a very quick snapshot of what you can look at for a diagram or what a typical infrastructure looks like for a small size network. And the last question that I want to cover in this speed round is by Sergey. And it's a long one, but he is describing a network topology that he's trying to understand how does routing work. And here's basically what that topology looks like. So in this diagram, he's trying to understand of how does the routers work and communicate for allowing PC1 to communicate with PC2. Now this is very basic entry level stuff, but let's quickly talk about that and kind of give you my recommendations for what to learn next to get a better understanding of how this can be configured. So his question is, so PC1 on the left is trying to communicate with PC2. Okay, we have like a ring of routers. So for PC1 trying to talk to PC2, we know that for PC1 it's going to go to router A, but it has two possible paths. It can go through router C or through router D, and then eventually go to router B and then to its final destination. His question is, how does this environment know about which path to take? Okay. Now, it all depends on how that network is configured, but the short answer is it is based on the dynamic routing protocol that is configured. When you configure a dynamic routing protocol like OSPF or EIGRP, which is probably the two most common routing protocols implemented, OSPF is probably more recommended because it can be used between different vendors, for example, like Cisco, Juniper, FortiGate. It doesn't matter. It is an industry standard routing protocol, where EIGRP is a Cisco-based protocol. So the great thing about using a dynamic routing protocol is that I can implement that on all of these routers, and they will dynamically determine the best path to all networks based on various information, based on the distance, even based on the bandwidth of the links between these routers. And with that information, it will determine the best path for, let's say, PC1 for communicating with PC2. So that is a very quick summary of what that details, of how routing works among these routers. So I would recommend to check out our CCNA video series on our website. Here's the link. And that will give you more information for learning about OSPF and EIGRP, including how it is configured. We also have practical labs, so you get to see us configuring it step by step, and that will give you more exposure of how this kind of thing works for routing across the network and looking at routing tables and determining what is the best path based on what the routing protocol determines. And we're done with this episode. So thank you very much for the great questions. And always, I want to hear from the rest of you guys. So if you have any questions about being a network engineer or anything in the networking field, post your questions below in the comments, and your question will come up in a future episode. So thank you very much for watching this video. Please subscribe to our channel. That means a lot. And also check us out and support our training program at routehub.net, where we have a lot of practical video training, a lot of cool stuff. And until next time, keep networking.